So what is a confidence interval? We create confidence intervals in order to estimate something that we don't know. We don't know the population mean. So the confidence interval is this process where we say we are pretty confident that the population mean is between this number and this number. So there's an element of uncertainty, but we can be 90% or 95% confident that we have a location for the population mean. So let's just pretend that we are studying rabbits in Lane County, and a biologist wants to estimate the population mean rabbit weight. How do you think they're going to go about estimating this? So what they do is they go out and, in a humane fashion, capture 60 rabbits, and they weigh them all, and then they come up with a sample mean rabbit weight of 680 grams. So that is our X bar. And what is the 60? That is our sample size, N. (680) is the sample mean. 0.95, that is the confidence level. So the researcher then says, I am 95% confident that the population mean is between 675 and 685 grams. Now I'm going to teach you the process of actually calculating what these numbers are. I'm sure you noticed that X bar is right in the middle of these two numbers. The confidence interval is plus or minus 5 from X bar, and 5 is the margin of error. So if we write 680 plus or minus 5, then our interval is 680 minus 5 and 680 plus 5, and we can write that interval as 675 comma 685. The parentheses enclose the boundaries of the interval. If I write 100 plus or minus 20, what is the interval that I'm talking about? 100 minus 20, comma 100 plus 20. So it's really 80 to 120 would be the confidence interval. And again, here I'm just building up some intuition, and then we'll get into a little bit more detail about how the 5 or the 20, that margin of error, is calculated. A confidence interval for the population mean, which is mu, which is unknown, has the form X bar minus EBM, comma, X bar plus EBM. Finding the sample mean from a sample is easy. Add them all up and divide by n. How do we find the EBM? Now, EBM stands for the error bound of the population mean. I called it margin of error on the previous slide, and that's what we call it in Math 105, but we are going to be calling it the EBM here. So I'll have a formula that helps us to generate the EBM. How does the confidence level impact the EBM? If we were trying to get 90% confidence, that's still pretty strong. We'd have one value of the EBM, and if we were going for 9% confidence, then the EBM would have to be bigger. So here's your X bar, and you might have a certain EBM that you go plus or minus, but when you're trying to be even more confident, you have to cast a wider range of values, because that's how you can become more confident that you've captured the elusive and unknown population mean. So a bigger level of confidence requires a larger EBM, error bound. And let me see which slide I'm on here. Yeah, this is the last slide of this video. So a population parameter mu is unknown. The sample mean is a point estimate of mu. It shouldn't be that far off, but it's not going to be exactly perfectly matching mu in the real world. It's a little bit off. So in 8.1, we construct a confidence interval for mu using x bar. And in 8.1, the population standard deviation is known. In section 8.2, we don't know sigma, we only know the sample standard deviation. So that's the main difference between 8.1. We are still constructing a confidence interval for mu in 8.2, but we only know the sample standard deviation, S. So we have a little bit less information to work from, and our process is going to be a little different. So you'll see that as we work through this chapter.